Welcome to Smart Software with Smart Logic, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justice Eapen, and I'll be your host today. I'm a developer at Smart Logic, a Baltimore-based consulting company that has been building web and mobile software applications since 2005. I'm joined by my co-host and colleague, Eric Ostrich. Say hi, Eric.
Hello.
And we're also joined by a very special guest, Mr. Jeffrey Matthias from community.com. Say hi, Jeffrey.
Hello.
So our first series covers Phoenix and Elixir in production. So Jeffrey, that's what we'll be talking about today. Do you want to just give us like a quick overview of community.com and your experience using Elixir and Phoenix in production across your career?
Yeah, so I'll try to explain Community. It's a product that's kind of cooler the more you dig into it, and I've discovered I really suck at selling it. So I'll do my best, and then we'll go from there. We are giving people the opportunity, and when I say people, we're talking about people with fan bases, the opportunity to interact with their community, with their following via SMS, via text message, instead of having to be stuck on social media platforms. It gives them a lot better control. It also means that you can actually we provide a phone number, like you are texting with those people. So we've soft launched at this point. If you do a little digging on the internet, you can find places where you potentially can come up with phone numbers for Ashton Kutcher, Metallica, and Gary Vaynerchuk. And we're slowly rolling out more clients. But and then we're trying to, one of the big things we're doing is building tooling so that they actually really can manage that relationship between themselves and millions of people. But and again, it's kind of interesting because it's through the interface of that text messaging app that you already have on your phone. That's what I'm working on here at Community. In terms of working in production Elixir, I got my start in either late 2015 or early 2016 working at a company called Parkify. We were putting sensors in parking spaces so we could get live occupancy data. And that system actually originally started as Java, and we started to introduce more and more Elixir as time went on, initially as background workers, and then it started to do customer-facing applications as well with Phoenix. And then after that, I was at a company called Enmesos, which is load balancing of the power grid. And that was a pretty exciting and very different use case where we actually had hundreds of thousands of assets out in the real world that were represented internally by gen servers. So we were collecting telemetry and making decisions on what to switch based off of what the current situation was and what the current telemetry was for those individual assets. So that's pretty cool. Spent a while at Weedmaps working on there and worked on building out the online ordering and order and driver tracking for, in California, you can have marijuana delivered to your home. And so that was pretty exciting getting to do live map stuff. And that was both Enbala and Weedmaps. We got to leverage the channels pretty well for being able to actually drive live dashboards. And with Community, our biggest challenge has been scaling. And so that's where Elixir has come into play. Is just there are periodic things that happen that just spike our traffic really heavily, and being able to manage those heavy traffic spikes has been great.
All right. So what made you interested in using Elixir in production?
Yeah, so back when he first really announced it, Jose was making the rounds. Jose Valim, the creator of Elixir, was making the rounds, going like city to city, actually introducing Elixir to people. And I sat in. There was a meetup, the Denver Full Stack meetup, and he did a presentation on it. And I watched it, and it just right over my head. I was like, why do I care? But for some reason, 2014, I was sitting in a conference talk with Ben Tan. I'm trying to think. I think it's Ben Y. Tan Ho. I apologize if I got his name wrong, but he's the writer of the Little Elixir and OTP guidebook. But I don't think that was out at that point. But it was a RubyConf talk in 2014, and he was talking about Elixir, and something about that conversation just clicked for me. Shortly thereafter, I left SendGrid and was at Parkify, which is the first place I mentioned that we had that. And turns out that one of the other engineers there was super excited about it too. So Brad and I kind of put together a plot on how to get our CTO to let us start trying out Elixir in production. And that started with background workers, where we were just reading from a queue, processing data, and then sticking it somewhere else. And they just didn't cause us problems. Like the biggest challenge around it then at the time, especially, was figuring out how to get deploys out. But as far as once they were up and running, we had these simple little apps that were just bulletproof. And it was a pretty cool way to get into it. especially because the first apps I ever wrote were actually just straight Elixir OTP apps and not Phoenix, which is, I feel like Phoenix isn't as heavy-handed as for those who are coming from Rails. There's a lot of people who really, like, if they learn Rails and Ruby at the same time, they're stuck. They actually don't really know where the division is between the framework and the language. I don't feel like Phoenix has that problem in anywhere near the same stuff. It doesn't, especially because it can't open up and actually change the behavior of existing classes in the way that Rails happily does. But that said, it was still a really great way to get into it by having to learn OTP and having to figure out how to do a lot of my own background processing and stuff like that before I ever hit Phoenix, which does a lot of that concurrency and parallelism for you. But so then I finish up. So after we got those little apps running, we started expanding and it started becoming more and more of the platform. And at that point, I was pretty hooked. I have actually worked pretty hard to make sure that the jobs I've had one job since then and that was just very briefly, that wasn't in dealing with Elixir, but I really enjoy the language.
So what are some of the high-level advantages and disadvantages of Elixir?
In my experience, a lot of people, one of the biggest advantages, I mentioned the parallel work and the concurrency already, and that's really nice. It does make those concepts really easy. But in my experience, one of the biggest things is that Elixir and functional programming in general maps to the way that most people think about programming or think that programming should work before they ever actually learn to program. And then we beat them down and teach them about object-oriented designs and programming. And I'm not against object-oriented stuff at all. That's not what I'm saying here. But it actually really is a pretty big mental shift to get to everybody's original basic concept of like just kind of going through things in a pretty detached way to instead there's this little ball of information and only certain functions that are attached to it. So I think mentally for me, it maps to, it's easier to think about in reason than object-oriented programming. So I got that functional aspect of it. The syntax is really nice. Coming from Ruby, I did work in Java, but the majority of my career was Ruby before this, and having similar syntax is great. But a lot of it is actually I don't read very well, and there are certain syntaxes that are easier for me to read and parse visually than other syntaxes. So it's really nice from that standpoint. And the other thing I've noticed is that one of the biggest things I've had to do in this career is, because there's never enough Elixir developers, is teach engineers, existing engineers who've got long, wonderful careers, and teach them Elixir. And the adoption rate, like the speed at which people can pick up the language is actually surprisingly fast. And I think that is probably its biggest asset. So I just named a bunch of things I really like about it. I think that from a disadvantage side, though, I think the biggest challenge is deploys, and we're in way better shape than we were back in 2015, 2016 in terms of deploys and how to get them out the door, especially with the concept that most people think of as how we do modern day deploys, which is you have some sort of artifact that you're dropping into an environment based off of the environment variables. That's the only thing that's going to switch its behavior. So you're actually sticking the same compiled code all over the place. And that is not what Erlang was geared towards when it was originally created. And, to this day, a lot of Erlang's original design still shows up in Elixir. So one of the biggest challenges we had, for a long time was dealing with the deploys. It's getting better, but everything we're doing is still has that feel of a hack to it in terms of getting releases out. And I definitely recommend releases over mix run. We can touch back on that if you want, but the biggest thing is releases are still a kind of a big pain in the butt. Bitwalker, Paul Schoenfelder, came out with Distillery 2.0 last summer, I believe, and that has helped us in terms of giving us flexibility to get releases out, but the actual system and process itself is still pretty counterintuitive. So I think that the biggest challenge is getting releases out. The other one that I come across regularly is that the level of parallelism can make testing hard sometimes, and people get really excited. It's the language is great, and then it supports testing as part of it. Like there's we barely step outside of the core standard libraries testing XUnit, right, for getting our testing done. So it's really great in the sense that support was there from the get-go. It was designed with testing in mind, but actually trying to figure out how to deal with a lot of the parallelism can be a challenge.
So first of all, I just want to say that the You mentioned like the accessibility of the syntax, and that has definitely been a trend that we have seen with all of our guests, or not, maybe not all of our guests, but some significant portion of our guests have mentioned that. I want to move on to some of the like deployment system level questions that we have. And so I'm wondering right now and throughout your career, how have you hosted Elixir applications?
But back when we didn't really have things that were very good for switching up reading from the environment, our very first pass on it was to actually have our CI compiling different versions for the different environments. So staging got its own version compiled, built out as a Docker container, and then we just deployed that Docker container. Production had that. And to be honest, it worked, right? Like it was not, and it didn't involve anything that felt super hacky. We just had to compile it and we were using system getenv in that particular compile environment, had those variables available. And worst case scenario, that's actually a decent fallback if people are struggling to deal with other stuff. And then there was the Distillery 1.0 was a big shift for us where we were building things out in containers. Distillery 1.0 was great in that it gave us the ability to have a single artifact that could run in one environment. They could run in multiple environments, but everything that came in had to be a string. And there are times where you're actually pulling things for the environment, especially dealing with library code. Like older libraries especially weren't taking their configuration at startup. They were actually taking their configuration in via the application environment. And so you didn't have the ability to actually manipulate or change, convert a string to an integer. And so that's been a challenge. So Distillery 2.0 has given us the ability to specify that. It's still feeling kind of tough, but right now the way that our deploys look is that we've got CI building out our artifacts, our binaries for the system, and then we build out Docker containers relative, or for that. We store those in a Docker repository. We use key.io. And then our actual deploy system is using Mesos, and we've got a bunch of extra additional tooling running around that. So Mesos is probably on its way out in terms of, Kubernetes seems to be taking over the world right now. One of the things that it really brings to the table that Kubernetes doesn't have is it's significantly simpler. And there's no such thing as a small Kubernetes cluster. Like once you've got Kubernetes running, you've got you're in that ecosystem. And we're in a position where we initially got our stuff set up with Mesos, and we're using a couple other tools on top of that. Some are custom internal, and some are from a company called Nitro, put out an actual deploy tool built on Mesos called Enmesos. But we're using that stuff, and right now our deploys are. I don't actually personally like the concept of continuous delivery, but we're basically a push button deploy. I've got a single command, a single line to run on my box to control the remote stuff to actually deploy from those repos. And so we're dropping, we're pulling down Docker containers. The environment variables I was talking about that are so precious to us, right, are done specifically by environment. And that's all done through configuration through the Mesos stuff.
Cool. So for the Docker container, do you do like a multi-stage build, and then the final entry point is the release binary? Is that?
Yeah, so I'm trying to think of it now. I haven't thought about this stuff in about 2 months. Trying to see if I could cheat and just go back and look at some of my Docker files. So yeah, I'm trying to think. I apologize. I honestly am not as awesome at Docker as I should be, especially because my brother wrote one of the books for O'Reilly. But yeah. Yeah, Docker Up and Running by Carl Matthias and Sean Kane. So yeah, no. So I honestly when you say multi-stage versus not, I mean they're pretty shallow containers. We're not pulling a lot of dependencies in front of them. So I'm not sure if that actually directly answers your question or not.
I think that's the new recommended way if you look at the Distillery docs. So cool. Anyways, with Mesos, this is the first time I've heard Mesos in the wild. Are you able to get zero downtime deploys with this setup?
Yeah, and it's the boring answer where it's rolling deploys and not hot code. I'm going to apologize in advance to anybody who was hoping those were the words that were going to come out of my mouth. But we're in a position where we don't have to necessarily, we don't have any long running processes that are so precious that we have to maintain that state. We do have processes that are potentially, when I say long running, we've got stuff that can take 5 to 10 minutes And so if we're trying to deploy when that's going, we actually we've got shutdown handlers that will basically start weeding off the connections and start refusing new traffic on those, but let them run until they're done with their work. In the meantime, we're spinning up new nodes and then rolling off the old ones. And so our zero downtime does exist, and inherently the nature of our business or of our domain, there's a lot of queuing involved between our stages of processing. And that gives us a natural way that basically when we send out the signal, we basically tell each of the servers like, hey, stop processing new messages, go through the rest of your shutdown. And so during that, and we've got about up to 5 to 10 seconds where it needs, they need to stop processing, and then we move on. So we've got, the apps themselves have shutdown handlers. So we're just doing the boring old rolling deploys, but we do have zero downtime.
Cool. Yeah, it's boring, but it works. And it's a lot more stable than the hot upgrades.
One of our biggest challenge around that actually is that we have certain rate limiting systems that we have to pay attention to and recognize in terms of our stuff. And so when we actually are spinning up new servers, we have to adjust the rates across the servers so that they're all recognizing, because collectively they have to aggregate up to a maximum rate. And so we've had to build out. We basically query Mesos and say, hey, actually Sidecar at that point. But we're querying the system and saying, hey, how many nodes are there actually running? And our nodes themselves are self-correcting to make sure that, and doing the math, figure out what their personal max rate or their individual max rate should be. And I think that's the biggest challenge we've had. And it wasn't like this is one of those things where Elixir actually makes that relatively easy, because we just have a process that just sits, that's a long living process that just sits there and just, queries on a pretty regular cadence to see how many there are in the system, and each of the nodes do adjust pretty quickly.
Awesome. So that kind of leads us to our next question. So you have a bunch of nodes. Do you cluster them?
Yeah. So, it's funny. Right now we don't, but we will be shortly. We actually have, I think our system is right now 5 separate Elixir applications with more on the way, and each of those have multiple nodes. The nature of most of them, we don't actually need that, although that potentially would present a different solution for the rate limiting I was just talking about, where if we actually could just do a pub sub broadcast across all of the nodes, then what the new rate should be instead of letting them individually correct. So that would be one of the few advantages in terms of like further back in our system. But our client facing stuff, right now our dashboard is built around polling, and we are going to be switching over to being able to push stuff via sockets. And that's one of the easiest places. We could use Redis for the pub sub, but connecting our nodes, like our system does report, not only does it report how many nodes there are of each service, it actually reports the IP addresses. And so with that, you can connect relatively easily. So in our relatively near timeline, we're going to be doing that. And then when I was working at Weedmaps, that was the other place where we actually were running connected nodes. And that was largely for the channels, to be able to use Phoenix channels and drive a live dashboard. And honestly, it's nice. Like the node stuff, for the most part, just works. You do have to pick parts of your domain where the consequences of any sort of separation of your nodes. My brain just totally blanked on the right word for that. When you have that
net split, is that?
Yeah, it's not what I was looking for, but that absolutely works. Yeah, when you definitely want to choose it in your domain, like when you're choosing to rely on that as part of your mechanism of communication between your servers, you have to choose areas where it's okay if things are slightly out of date for a short period of time, or so the data that you want to rely on passing via those routes has to be stuff that has low consequence if there are failures. But
I think cap theorem might be the other thing I'll toss forward, I guess.
Yeah, and that partition. Yeah, in fact, that was the word I was looking for. The P in cap. Yeah. And so that's exactly it. Is like there. We got to the point where we introduced that, and the front end, our front end developers were actually incredibly pleased with the library, the Phoenix library that is the JavaScript library for dealing with the channels. Like they really liked it, and it got to the point where our front end started suggesting like, well, could we use channels here? Could we use channels here? And we're like, hey, dial it back. These are not actually ideal places. We need to figure out what does it look like if there is that partition. like what are the consequences for it? And so that said, from a user experience standpoint, when they're working, man, channels just really drive home a really clean experience.
Yeah, I think there was a 2017 Elixir Conf, I want to say. Someone did a GraphQL API over channels. So just do everything over channels.
Yeah, it's really tempting, and it's funny. GraphQL actually would probably solve one of the biggest challenges we found, which is like we're like, okay, we're here to write channels, and this was, in the particular project I'm thinking it was the first time we'd really tackled channels. It's like, okay, what are the actual conventions for message naming? We're moving away from REST. We don't have these REST concepts of like post and these RESTy URLs. Like what do we actually call this stuff? And we had to work with our front end team and actually design an API spec. And to be honest, I think that fortunately it wasn't huge, but there was enough inconsistency there that like going back and auditing, it's because we were kind of dealing with things as they came up. Like some of our original decisions were just awful. And trying, and they may exist. Like I'm sure somebody will be listening to this as I say these things and screaming at me that like, why aren't you just looking at X spec that already exists? But I couldn't find anything as far as like recommended WebSocket specs in terms of actual action naming and payload stuff. So we were using JSON API for our actual payload structure, but it like the channels, the WebSockets themselves, I'm still waiting to see strong conventions arise around what that stuff look like. But GraphQL itself could be one of those answers.
Real quick before we move on, there's a thing called asyncapi.com. So it's open. It's Swagger Open API 3.0 for WebSocket stuff.
Nice.
So that's something to at least document what you got. I don't think they could push anything.
Okay. Well, and that ties in with as much as Elixir is magical in so many various ways. Let's be clear. When I say magical, I mean fun to work in and does lots of cool things. It's not magical in the way that you write a line of code and there's 50 things that happen under the hood, like certain other frameworks in languages. But it's as awesome as it is from that standpoint. There are still a lot of things that are common, like it hasn't changed how I work as a developer. And one of the main things that, that I drive whenever I come to a company and that process doesn't already exist is whenever you're starting an API, one of the things you do is you work with your clients and you just agree, you document what that API looks like. It's painful because nobody likes to write documentation. Nobody likes to do anything, but what it does is help you drive a consistent API. And so that would be, so a tool like that for documenting that stuff is great. And that without even having specific convention recommendations, that should be, your first stop.
All right. So how does your Elixir applications compare to, I don't know, anything else you might have had? I guess this might just only go back to Parkify with the Java.
It's nice. We live predominantly in a world where performance considerations just aren't a thing anymore. The scaling that we can hit is fantastic. Like Phoenix itself under the hood handles every incoming request as a separate process. Before that, I came from a world where we were running, what was it, Unicorn or something like that, and then eventually Puma with the Rails stuff to try and just run literally entire versions of the application just to be able to serve multiple requests. And so that kind of horizontal scaling was challenging. Phoenix just out of the gate leverages the concurrency model and the parallelism, of the Erlang Elixir ecosystem in a way that I don't focus a whole lot on that like I used to. One of the biggest challenges for us, and this isn't specific to Elixir, this is specific to any application you write, is just you got to make sure you're instrumenting your stuff and actually have full-on metrics for what how your application itself is performing. And that's the biggest thing is that for us, we spend a lot less time worrying ahead of time about what is going to scale and what isn't, and it's more about instrumenting it and figuring out what we have to scale. But a lot of times that just means instead of having to build out more nodes, we literally can be like, we can find bottlenecks in a specific thing, identify if it maybe we ended up with a single gen server that, and a gen server has to handle its own messages serially. So it can potentially be at a bottleneck. Sometimes you take advantage of that, but other times it turns out, hey, we weren't thinking, we made this decision. And there are ways to actually remove the state aspect of it or, pull it away from being a gen server and actually just flat functional file instead. So I think the biggest thing is that in general, it performs as well as we design it. And every once in a while, we get a little bit process happy, and we're using processes when we actually probably could have gotten away with pure function.
So our next line of questioning is around like background task processing, libraries, et cetera. I'm curious, how are you solving background task processing? You mentioned earlier a little bit that you're writing them on your own. I'm curious, like, what does that look like in practice?
Yeah, so I've tried a host of different ones. The one I think that's pretty well known that I've never actually used is Verk, which is like the sidekick style. The sidekick style one. My general go-to default is literally spinning up unless like the very first pass I'll have on something, and it depends on what it is. But if it's a scheduled task, or if it's something that doesn't have to be like exactly on the dot when it happens, but it's something that needs to be recurring regularly in the background, is literally just start a gen server that then sends itself a message when it's done, or when it starts, it uses process send after. That actually could cover probably 80% of the use cases out there, and it is simple, right? Like, and depending on how many jobs or anything like that you have, then that would absolutely be my first place to start. And then you could start getting into other things that I've had success with. Like, I believe Quantum is one of the things where you give it a cron tab style time schedule or whatever, and it'll kick things off. At the moment, we're actually leveraging Mesos has scheduling built in with cron style syntax, and it's just hitting an endpoint to kick off work for us. But like, I've used all three of those with happy success, and wouldn't tell anybody to shy away from anything. Again, I think the first step is to actually look at what the system itself can do, or what the beam itself can do, and like the background long running processes, especially something like that gen server I'm talking about. Like that's often a scenario where you don't even necessarily need it to keep state. If you do, then you need to be potentially thinking about how to back up that state and stuff in the event of crashes. But if it's not, then like having a supervised gen server that just sends itself that send after actually works pretty well. Supervision tree, the supervisors, which is one of the main features of the beam is that supervision tree. That supervision tree can guarantee, all but guarantee that process of it is going to be up and running. And then, like anything else, you should have some sort of monitoring or metric, some sort of alerting in case your job doesn't run, so that it does, that you do become aware of it. But first pass, look at what you could just do with Elixir and its own background processing.
Yeah, we started with Verk mostly we were incredibly familiar with Sidekick, and it's been interesting to like see how it's unwinded to just like, oh, not like we just did a new project, and it's like this is the first real production server where I feel very comfortable with just gen servers, and like I know it's going to work.
Yeah, no, that's great. I love hearing that, because it's I think one of the cool, one of the very fun things about this this whole ecosystem is, first off, the more I learn, you see all these cool things you can do, and then you go build these really cool things that you could never do in another language. And you're like, wow, look at the way I did this. And you show it to somebody, they're like, oh, you didn't know about, and they name X that was an existing feature in the language. It's like, this Erlang has been around for 30 years or whatever, and it turns out that they too, like the developers behind Erlang, were also aware of how awesome their system was, and they have been building tooling around it ever since. The downside tends to be that it's awful syntax, or it's really not intuitive, like by today's standards. I feel like development culture as a whole, and Elixir definitely is pushing that, is that like readable, clean APIs is a thing. And admittedly, a lot of the existing APIs in Erlang can be tough to grok at first. But that said, yeah, it's really cool to get into these, realize that a lot of the stuff we pull in is actually often overkill, that really the core feature set of the language and the ecosystem of the beam actually will deliver those values. So,
all right. So we've mentioned a few libraries like Phoenix, Quantum, Verk, and a few others. Is there any other big ones, maybe outside of Ecto, that jump out as stuff you use?
All right, so there's a couple that are just good for maintaining code quality. Like if you're greenfielding an application especially, they're really hard to bring in after the fact, but Credo and Dialyzer or Dialixir are really nice if you can build that into your, from the very get-go. I like having that. People are going to be, again, I'm sure somebody listening to me right now hates me because I just said dialyzer. And again, if you've got an existing project, don't hate yourself enough to try and pull it in. It can be a real mess trying to clean it up. But if you're going from the get-go, it really helps drive specs. It's a way to encourage people to actually be specing out their public functions, stuff like that. Credo is great in terms of its static code analysis. Honestly, the biggest checks that we guarantee to have across all the tools are actually part of the existing library. Our CI doesn't pass unless you run a check for already to use the formatter to check that the code is whatever it changes are already formatted. And then the second one is mix, compile, force, warnings as errors. They're not extra libraries, but they are features that I wish every project had from the get-go. And they tend to be a little easier to add into the projects after the fact as well. As far as the libraries that show up in almost every single project I've ever worked on, I'm not in love with the API of it per se. It's a little too Railsy, but we use Ex Machina pretty heavily as a factory library. Every time, I know that Ecto, I think it was Ecto 2.0, they actually tried to drive it so that it was really easy to make your own factories, your own factory functions in there. And the thing that I've discovered is every time I go that route, because I'm like, this thing is totally overkill, or even better is, we're not actually using Ecto. I just end up replicating the same feature set. And at some point I'm like, all right, this is just getting silly. And to the point where even when I'm not using Ecto, I just pass in a dummy name, because you have to, when you use Ex Machina, pass it a repo name. But if you're never actually interacting with the database, you just give it a dummy repo name, like myapp.dummyrepo, which hopefully if somebody sees that, they recognize it's not a real repo, and you still got the ability to, to use those factory functions. And then we just build additional data type, functions in that same factory file. Like if we need a phone number, we construct our own helper functions to do that. So I'd say that that's probably the one that I end up pulling in, and it's surely out of laziness. Now that I'm used to the that particular style of working with the factories, just kind of keep doing it. I'm trying to think of I don't know. So I can't believe I just forgot this one. The other thing, and you're going to notice that both of these dependencies are pretty much test specific. Testing is probably the place where I feel the most comfortable. I use MOX, MOX, the mocking library built by Jose in response to his own article about mocking. I'm sorry, about mocks. I need to correct myself. Mocking is a noun, and mock is a noun and not a verb. But we use that pretty heavily, and it's the point where I don't know anything I can't really do with mocks at this point that I was able to do in other languages. But it has a nice barrier to entry that it forces you to have behaviors defined for the things that you're mocking, and behaviors are not heavily enforced in Elixir, but that actually does push us to have those standardized built-in interfaces for the stuff. And it also there's enough of an overhead to using it. You really do have to choose when that is the route to go versus finding some other way of dependency injection, or just honestly centering your code around being functional. As opposed to actually needing to have those heavy reliances on outside stuff. So I think that if I had to do this over again, I would actually name MOX as the number one thing. And then Ex Machina is helpful or whatever, but it's the reason I like Ex Machina is because it helps me build out randomized data for my testing, and you should never, you should avoid hard coded values in your tests as often as possible. But MOX to me is definitely a bigger thing. And then, Phoenix.
Do you have any third-party integrations that you've worked on that either pose any difficulty for you or were interesting? Yeah,
that's a great question. So I think I've used Rabbit at a couple of different jobs, and and that's you host it yourself, but I think that sufficiently counts as third-party because it comes with its own API. And we've pretty much exclusively used the AMQP library for that, and it works well. But it is just
that's RabbitMQ, right?
That's RabbitMQ is the actual queue system, and then AMQP is the Elixir wrapper around an Erlang library, if I recall correctly. And it's about as far from intuitive as it gets as far as working with it. And for example, and we actually had to marry a Rabbit consumer with a GenStage producer recently. And like, that was hard, but it still is like the biggest, like probably the biggest dependency in terms of like consistently across different companies that I've used. I think this is the third company that I've been using Rabbit with. And this is, for anybody who's again yelling at the podcast, Broadway just came out last week. So, and they haven't officially started supporting Rabbit yet anyway, I don't think. But so that's why I had to do this stuff on my own. Although I'm lying, I say on my own. Jose Valim actually helped us a little bit with that. So I think that's probably the biggest one. I'm still looking for a metrics third-party system that I'm in love with. We're using AppSignal right now, and it's the closest I've gotten to being happy with something. Given how much of Elixir is background processes, they really only provide immediate first class, like plug-in, like plug and play kind of support for the Phoenix endpoints and Ecto. But like we're using Cassandra right now for stuff, and for some of our stuff, and we're reading off of queues, which have nothing to do with endpoints and with the Phoenix plug endpoints. And so we're definitely still having to roll out a lot of our stuff there, which is not the end of the world at all. It's just the only challenge is that it shows up in AppSignal as a different screen on the metrics. And that I think in general, every running application out there should have some sort of metrics system that it's interacting with. I'm trying to think of other stuff that we've really kind of struggled with. I mentioned Cassandra. We're still in search of a driver that we absolutely love. Or a library, I should say. There's the one we're currently using is Erlcast, which is a Erlang library, and thank God we can just jump back and forth and just grab Erlang libraries willy-nilly. Then there's Xandra, and they both have, like, Xandra's problem is it didn't have SSL encryption supported out of the box. Like, it was kind of hard getting communication for the maintainer about getting that added, whether it was us doing the work or somebody else. And then Erlcast actually just brings with it a whole pile of awkward syntax because it is an Erlang library, and then it uses NIFs, native implemented functions, with a C++ driver, and that actually has been kind of a pain from a build standpoint because the C++ driver occasionally changes on us, and we've had to figure out ways to lock into versioning on that.
Well, we're going to move on to our last set of questions here, the first of which is, do you have a story where Elixir saved the day in production?
Yeah, so I think that the biggest thing there is that when it comes to debugging your runtime application, Elixir is awesome. One of the big reasons that I like releases as much as I do is the ability to jump into remote console and actually interact with your running system. There is nothing like hunting down memory leaks. I think everybody's had, the majority of the people who are listening to this have had the experience where something was going wrong. Their box is, running out its memory and then falling over, restarting from whatever, outside services have that. And they're trying to figure out, what on earth is going on? And so being able to do something as simple as just asking the system, hey, here's an anonymous function I wrote that just asks for the top 5 processes in terms of memory usage, and what are they? And just being able to jump into your running application where you actually have the issue happening and you're not trying to simulate it or do something else somewhere else has been absolutely huge. Now, there are some companies that don't want their developers touching production servers, and that's a philosophical choice of that company itself. And maybe at that point you have to work with ops or whoever it is that's your gateway there. But the majority of the companies I've worked at, I've been able to do that, and being able to actually jump in and actually hit that, like do something like write that stuff or query the VM on it. And this is actually the first company I've worked at where we actually have Observer running live against our remote servers. But that would also be another way where you're not potentially at risk of running arbitrary code, but you're, and whatever issues can come with that, but you still can get a lot of insight into the beam. So it's not that, a lot of it is we don't actually just see a bunch of the issues that we have just from the design philosophy of let it crash. There's a lot of stuff that just doesn't come up as issues. But when we do have them, being able to jump into the live running servers and debug them directly is priceless. I think it's, at the end of the day, it's probably, I mean, it ranks in my top 3 about just one of the reasons that I like Erlang and Elixir, and I just totally didn't mention it at the beginning of the episode, right? But yeah, being able to connect remotely. And from that standpoint too, if people are trying to wonder what their start is, like how to get into that, I mentioned Remote Console, but there's a book from Fred, I'm going to butcher his last name, even though it's really, I think it's just Hebert, but Hebert. But it's called Erlang in Anger. I think it was co-produced with Heroku, and like that is a go-to guide for anybody who wants to know. All the concepts transfer straight over to Elixir because it's all about debugging the beam and dealing with that. And again, I'll repeat the name. It's Erlang in Anger, and if you just search Erlang in Anger, you should be able to find it. It's a free PDF, and everybody should read it.
Yeah, we'll make sure to link that as well. All right. So our final question: if you could give one tip to developers out there who are or may soon be running Elixir in production, what would it be? I have spent a long time, and this isn't even necessarily about production versus just kind of learning on your own. One of the most valuable, when people still start feeling like they really know what they're doing with Elixir, one of the things that they should do is go and implement the Gen server module themselves without looking at the existing code. Just set it up. Give yourself some tests where you build a Gen server, and you have some testing around your Gen server. And then you go and, at the very top of the file where you say use Gen server, you should switch out Gen server for a module that you write. And it should do 2 things. It should be a drop-in replacement for Gen server. And it also should handle sending the messages, right? genserver.cast or genserver.call, but I think that going through that exercise is the best way to become familiar with what's happening under the hood. With the majority of OTP is just an expansion of what you're going to learn there. And one of the catches there is, you've got to make sure that you're handling messages on like cast, that it actually is, handle call. You're actually making darn sure that the message coming back matches the request you made. Use makeref, just a little hint there. But doing that is one of the things that really I've watched people, it just clicks in their head, and suddenly so much of Erlang and Elixir becomes demystified. And so I would really recommend that for people. Doesn't necessarily, again, tie directly into getting your apps into production or running it there, but it will help you understand what's happening under the hood in a way that nothing else will.
Okay. Well, that is great advice, and this has been a jam-packed episode. It went a little bit longer than usual, but I think that is a good thing. Jeffrey, we're really glad that we were able to have you on the show. Do you have any final plugs or asks for the audience before we let you go?
I just throw out there, I am Idle Hands, at Idle Hands on Twitter, and sometime in the next, I don't know how long it's going to be, sometime in the next probably 4 months or so, a guy named Andrea Leopardi and I are going to have a book out, or at least the beta version of a book out on testing Elixir from Pragmatic Programmer. We're working on it right now, and again, I don't know the exact time frame, but just keep an eye out for it. I mentioned that testing can be, there's some challenges in there, and we're trying to give people a reliable guide, at least to start, on how to start tackling some of the bigger challenges in testing with Elixir.
Super. Jeffrey, thank you so much for joining us today. Once again, this has been Smart Software with Smart Logic, talking about Elixir in production. Join us next time for another conversation on Elixir. Jeffrey, thanks so much.
Cheers. Thanks for having me.